Polyatomic ions, we studied these polyatomic ions last chapter. We had to build them. Fact is, this is what we did with them. These are polyatomic ions. More than one atom ions. And all we learned how to do was figure out what their structure was. What was hooked to what. Okay? So now, the reason why we did that was because last chapter we were studying covalent bonds, and these are covalently bonded. So inside this is covalent bonds, but that negative charge is going to be attracted to a positive charge someplace else. So it's still going to be an ionic compound. So they share in here, but there's an extra electron that makes them attracted to a positive piece. Okay. You got the list, and they did it by charge. A couple things, a couple of patterns to notice. The most complicated one is the first one on your list. It's acetate. Okay. Then nitrate. And after acetate, most of the things that end in ATE are going to tell you what they're next to. So nitrate is nitrogen next to oxygen. So ATE means lots of oxygen. You don't have to copy this list. It's sitting right in front of you on a bright yellow piece of paper. What you want to look for is patterns. No reason for you to copy this list. I just handed it to you. I'll always hand it to you. Okay, so nitrate is NO3. Then there's nitrite, which is NO2. Both of them have a 1- charge. And we've drawn both of those last chapter. A couple homework assignments where we had to draw NO3 and NO2. Okay? So ite ending always means one less oxygen than the ate ending. So if you see ate or ite, you will know it's polyatomic, and you'll have to pick the right one. Every name you wrote for chemicals last night ended in IDE, right? So when you take them off the periodic table, they end in IDE. If they got oxygen, they end in ate or ite. There are 2 polyatomic ions that end in IDE. One of them is hydroxide. Hydroxide's named backwards because it's hydroxide and I put the O before the H. But it's always written as OH. Permanganate is an ATE, and manga is manganese, MnO4-. The other one, -1, is cyanide. And the reason why hydroxide and cyanide end in IDE was when they were coming up with names for stuff, they thought they were elements because they hadn't separated the oxygen and hydrogen or the carbon and the nitrogen from each other yet. So they got the name for the polyatomic ions, thinking then they gave it to them when they thought they were elements. It turns out they're not elements, but they didn't change their name. Then there's a whole bunch of chlorine and oxygen. Okay, chlorine and oxygen. Chlorine with 4 oxygens, 3 oxygens, 2 oxygens, and 1 oxygen. They all have the same charge. They all end in ate or ite. Okay, and what it is there's a. We said earlier that ite always means 1 less oxygen. So chlorate has 3, chlorite has 1 less. The prefix hypo means even 1 less. So hypochlorite is 2 less than you started with. 1 because it's ite, 1 because it's hypo. Chlorite is the polyatomic ion in bleach. Bleach is sodium hypochlorite. That's what bleach is. And the prefix per means 1 more oxygen. So chlorate and then it has 3, so perchlorate has 4. Oxide is O2-. Peroxide is O2, 2-. 1 more oxygen, same charge. The 2- ones, there's sulfate and sulfite. Carbonate. There is no carbonite. Han Solo's really happy about that. Chromate, chromium and some oxygen. Then there's one called dichromate that's almost twice as big. It's got twice as much chromium and almost twice as much oxygen. And silicate. So this is just that list you got in front of me. You don't have to memorize, you just have to be able to use it. And then there's some that are 3 minus. Phosphate. Guess what the next one is? Phosphite, 1 less oxygen. You have arsenate on there, we could have arsenite. And positive ions, the positive ion you really have to worry about, we're going to run into really often, is ammonium. Ammonium is the one positive ion we'll run into really often. Okay. Not ammonia, ammonium. So it's named like a metal because it's behaving like a metal, lost electron. Technically mercury 1. How the heck is that mercury 1? See a whole bunch of 2's. How is that mercury 1? Well, what's the charge on mercury? Well, there's 2 mercuries that add up to 2 plus. What's the charge on each one? 1. The Roman numeral is not about how many, the Roman numeral is about charge. So the charge on mercury there is 1. This is just a tiny fraction of all the possible polyatomic ions. You walk into a Chinese restaurant, they usually have a sign up that says no MSG. MSG stands for monosodium glutamate. Glutamate is a polyatomic ion. ATE at the end, glutamate. Always tells you it's polyatomic ion. And what it does is it gives the savory flavor. Okay, what happened, why they put it up there was a doctor wrote a little letter to the New England Journal of Medicine saying, hey, I've got some patients that have experienced difficulty breathing after eating Chinese food. That's all he ever wrote. Maybe it's associated with and maybe they're sensitive to monosodium glutamate. That's all he ever wrote. Nobody did any other research than that. The news media picked it up and started blaming it for thousands of deaths, for people dying of allergic shock from eating Chinese food. So they took all the MSG out. Now it turns out the number of people who are allergic to MSG is tiny. 0.1% of people. So they took away MSG. I like MSG. Makes my food taste good. All because nobody did the science behind it to find out if it was really a problem or not. The other one that you use all the time that affects you is sodium lauryl sulfate. Okay? And sodium lauryl sulfate is a foaming agent. It's in your shampoo, so it foams. And it's in your toothpaste, so it foams. It's what makes things foam. You'll find that anything that blows foam often has sodium lauryl sulfate in it. Okay? But sodium lauryl sulfate has a bizarre one when you're brushing your teeth, has a bizarre impact, and that is that it deadens your sweet receptors. The sweet receptors on your tongue get deadened by lauryl sulfate. So that when you go and drink, if you brush your teeth and then go drink orange juice, it tastes awful because you can't taste the sweet. All you taste is the sour and maybe a little bit of bitter if they put some peel in it. But you don't taste the sweet. So that's why it tastes bad. It makes it so you can't taste sweet, which is a strange side effect. Right. All right. So yesterday we said binary. Today we're going to say ternary. Ternary means one more than binary. So since binary meant 2, ternary means 3. The next one's quaternary. We're not doing quaternary. Okay, and the only way we're going to be able to write the formulas for chemicals that have 3 elements in them, the only ways we're going to be able to do it is if they have polyatomic ions in them. If they don't have polyatomic ions, we can't do it. Okay. So from a formula, you'll recognize there's got to be a polyatomic ion because you will see 3 capital letters in the formula. If you see 3 capital letters in the formula, there's a polyatomic ion in there. Go back and think about your homework. Every single formula you wrote last night only had 2 capital letters because it was 2 elements. Now we're going to have 3 because there's going to be 3 elements. But nothing else changes. The rule of naming ionic compounds is name the ions. So, NaNO3. I want to name that compound. First of all, 3 capital letters tells me it's got to have a polyatomic ion. Look at the first element. The first element is Na. Na is sodium. It's a metal. I write sodium. Does sodium need Roman numerals? Does sodium need Roman numerals? It's in group 1A, so it doesn't need them. So the first ion is sodium. NO3. It's got 2 capital letters. Let's look down, and you find on your list that NO3 is called nitrate. And that's it. That is sodium nitrate. What ions are there? There's a sodium ion, Na+, and there's a nitrate ion, NO3-. So we just named the ions. How did I know NO3- was called nitrate? Because it's on the list. It's right there, number 3. Okay. CaSO4. Well, Ca, I look up, it's a metal, so this is ionic. Its name is calcium, so I write calcium. Does calcium need Roman numerals? Well, it's in group 2A, so it doesn't need Roman numerals. So my first ion is the calcium ion, SO4, 2 capital letters. So I look on my list, SO4 was called sulfate. That's it. So it's really not, it's just recognizing it's there. Everything else is the same. Just got to recognize there is a polyatomic ion and then name it. Ooh, let's make it harder. CuSO3. Okay, I look up Cu on the periodic table. It's copper. It's a metal. So this is ionic. First word's going to be copper. Does copper need Roman numerals? Yeah. SO3. Well, if SO4 was sulfate, SO3 must be sulfite. One less. Now I just got to figure out the charge on copper. Well, I know it's 2 negative for sulfite. How do I know that? Because it says this has a 2 negative charge. So that means this whole thing, somewhere in there, there's 2 extra electrons. So my total negative is 2 negative. So my total positive has to be 2 positive. And since there's only 1 copper, that copper has to have a 2 plus charge. Okay, total negative is 2 negative. Need a total of 2 positive, only 1 of them. So this is copper to sulfite. Just naming the pieces. Got to figure out the charge. Remember, polyatomic ions stick together. They have a charge, so that 2 minus does not get multiplied by the 3. Those 4 atoms, SO3, somewhere in those 4 atoms are 2 extra electrons. So it's just 2 minus. Open parentheses, NH4, close parentheses, 2. Oh, what the heck is this? Well, first thing you'll notice, 3 capital letters, polyatomic ion. The part that's polyatomic is the NH4. And the NH4 is called, on the list, ammonium. Right there on the list, ammonium. And O is oxygen, but it's second, so it's acting like a negative, so that would be oxide. like, what is all that parentheses and stuff? Why is that there? Let's think about going backwards. If I write ammonium would be NH4 plus, oxide would be 2 minus. Do those add up to 0? No. So if I do the crisscross, I would be writing NH42. That doesn't work. I can't erase the 4 and put a 2 there because that means I'm changing what ammonium is. I don't get to change what ammonium is. So the only way I can say that I have 2 ammoniums is to put them in parentheses. Everybody see the need for the 2? So I can make my charges equal 0. I need parentheses. So I can say that's a group that sticks together. That's what the parentheses are about. So if you see them in some place like this, well, Fe is iron. It's a metal, so this is ionic. Does iron need Roman numerals? Yeah. OH, 2 capital letters. Find it on my list. Hydroxide. Now all I have to do is figure out the charge. Okay. Let's figure out the charge on iron. They want you now. So what's the charge on iron going to be here? Well, hydroxide's in the 1 minus group. Got a 1 minus charge. There's 3 of them, so I got a total of 3 negatives. So I need a total of 3 positives, so this must be 3 plus for iron, so it's iron 3 hydroxide. Not anything different than I do if there was 3 Cls. It's just I'm doing OH sticking together. And this is, why did I put the parentheses there? Why didn't I just write FeOH3? Well, because that says 3 hydrogens, not 3 oxygens too. So I got to put those parentheses to say I have 3 hydroxides. LiCN. Li is lithium. Does lithium need Roman numerals? No, it's a group 1A, so it doesn't need them. CN's 2 capital letters. I find it on my list. It's cyanide. So that's lithium cyanide. So, what about going the other way? We're at the formula for copper 2 sulfate. So, copper's symbol is Cu. It's a metal, it's ionic, I need to worry about charge. What's the charge on copper? We can't tell from the table, but right in the name it tells you that the charge on copper is 2 plus. Sulfate, look at that ending, ATE. It's important that you read the endings because they make a big difference now. You pick the wrong thing, you've got the wrong ending. Sulfate on the list was SO4 with a 2 minus charge. Does that add up to 0? 2 plus and 2 minus adds up to 0. So we're done. CuSO4. Okay. So it's just like we were doing last night. Figure out the numbers, make them equal 0. Gallium nitrate. So gallium is Ga. Its charge, because it's in group 3A, is going to make a 3 plus ion. Nitrate, ATE at the end. NO3 with a 1 minus charge. Does that add up to 0? No. So I'm going to put the 1 next to Ga. I'm too lazy to write 1s. And I'm going to have to put a 3 next to NO3. And to put a 3 next to NO3, I need a 3 outside the parentheses. Okay? It's usually different than what you're doing. Should be the same stuff, right? The only thing you're going to have some different kinds of pieces instead of just elements. You'll have something like ammonium chloride. And somebody's going to look all over the periodic table and they won't be able to find ammonium. Ammonium's on the list. And ammonium was NH4 with a 1 plus charge. Chloride, IDE, off the table. Cl with a 1 minus charge, because it's a halogen. Does it add up to 0? 1 plus and 1 minus adds up to 0, so that's NH4Cl. And barium nitrate. Barium's Ba. It's an alkaline earth metal, group 2A, so it makes a 2 plus charge. Nitrate. NO3 with a 1 minus charge. Does it add up to 0? Nope. So we crisscross. Ba1, NO2, NO3, 2. NO3, 2. Yeah. So that's what we're doing with this.